Now we'll take a look at interface configuration, beginning with how interfaces are identified. On M-series and T-series routers, interface names are formed from a designation, usually 2 characters, that identifies the type of interface, followed by the flexible PIC concentrator or FPC, PIC, and port number. The interface designations on EX-series switches follow the same convention. The consistency in the software means you need to learn Junos only once. Some common interface designations include GE for Gigabit Ethernet interfaces and XE for 10 Gigabit Ethernet interfaces. This identifier is combined with the chassis, module, and port numbers to identify the port. On the EX3200 switches, the FPC number is always 0. On EX4200 switches with virtual chassis capability, the virtual chassis member number replaces the FPC number. On both models, the built-in ports are PIC 0, while the uplink module, if installed, is PIC 1. Chassis, module, and port numbering always start with 0. Therefore, the first port is 0, the second port is 1, and so on. For example, on a virtual chassis-capable switch, GE012 identifies a Gigabit Ethernet port that is located on the first chassis, or chassis 0, on the module in slot 1 of the chassis, and is the third Gigabit Ethernet port on that module. For another example, let's look at a virtual chassis composed of EX4248 switches. In this case, GE200 refers to a Gigabit Ethernet port. That port is on the third chassis in a virtual chassis configuration and is on the first module, the built-in ports, and is port 0, the first port on the module. Now it's your turn. See if you can identify the XE110 port on the EX4200 switch stack shown on screen by clicking on the appropriate port, or click Get Answer to get the correct answer. There are a few special interfaces on Junos EX series switches. LO0 is the loopback interface, similar to the loopback interface in iOS. The addresses you configure on this interface are not associated with a specific physical interface. Because these addresses will always be reachable regardless of the state of individual interfaces, the LO0 addresses are often used for management traffic to and from the switch. ME0 in an EX series switch is an out-of-band Ethernet interface that you can use to manage the device. The ME0 interface is unlike other interfaces on the device because the device does not switch traffic between the ME0 interface and other ports on the device. It's used to communicate with the device itself. VME is a virtual management Ethernet interface in an EX series virtual chassis system. This interface is reachable through any of the ME0 interfaces on the switches that are part of the virtual chassis system. This interface ensures that you will not lose reachability with the virtual chassis system as long as one of the ME0 interfaces is connected. VLAN interfaces in an EX series switch allow you to configure an EX series switch to have a routed Layer 3 interface for a VLAN by associating the VLAN with a particular unit on the special VLAN interface. You then perform Layer 3 configuration for the VLAN on this unit. From using iOS, you are probably familiar with the concept of sub-interfaces. You use these to create multiple logical units on a single physical interface. For example, you can create sub-interfaces for 802.1q tagged interfaces that might require them. Junos has a similar concept called a unit. However, in Junos, all physical interfaces have at least one logical interface. All Layer 3 configuration always occurs at the logical interface, the unit level. Layer 2 configuration occurs at the physical interface level when it affects the entire interface, such as setting speed and duplex, or at the logical unit level when it affects only a single logical unit, such as assigning Ethernet switching parameters. When you configure an Ethernet interface without 802.1q tagging, it supports only a single unit. In this case, the unit must be Unit 0. When using an interface that supports multiple units, you are free to choose whatever unit number you like for each sub-interface. The special VLAN interface always supports multiple units. There is no requirement that you choose unit numbers that match VLAN numbers, although it is advisable that you do so. When you configure multiple units for a single interface, each unit is treated as a completely separate logical interface, so it is possible, for example, to route traffic between two logical interfaces on the VLAN interface. Just as you refer to iOS subinterfaces as interface.subinterface when entering commands on a Cisco device, you refer to units in Junos as interface.unit when entering commands. Under the unit level, you configure Layer 2 switching parameters and Layer 3 parameters under family stanzas, so named because of the different Layer 3 address families. On the EX series switches, you can configure two families. Layer 2 Ethernet switching configuration uses the Ethernet switching family. The parameters that would be configured with interface-level switch port configuration statements in iOS are generally configured under this address family in Junos. Configuring this address family makes a logical interface a Layer 2 switched interface. IPv4 configuration uses the iNet address family. The parameters that would be configured with interface-level IP configuration statements in iOS are generally configured under this address family in Junos. Configuring this address family makes a logical interface a Layer 3 routed interface. Junos allows you to choose to configure IP addresses directly on interfaces, or to configure the interface to be a switch port that is part of a VLAN. You can choose to enable processing of a type of traffic by simply configuring the address family on the unit. For IPv4, such a configuration will cause the software to behave in the same way as an iOS router would if you configured IP unnumbered on an interface. For Ethernet, such a configuration would cause the interface to be an access port and would cause it to belong to the default VLAN unless configured to be part of another VLAN. Examples of some things you would configure under a Layer 3 address family include addresses, stateless packet filters that apply to traffic of that address family, and unicast reverse path forwarding or RPF checks. Examples of some things you would configure under the Ethernet switching family include port mode, access versus trunk, VLANs, and stateless packet filters. You can assign descriptions to units as well as to main interfaces. This comes in handy, especially with the VLAN interfaces. Here you see that we have configured the special VLAN interface with two units. We'll give these units descriptions to help us identify them. Now a description. In iOS, you deactivate an interface with the shutdown command, and you reactivate an interface with the no shutdown command. In Junos, you can deactivate an interface in two ways. First, you can use the deactivate command shown earlier to deactivate the configuration. However, that command does not actually shut the interface off. Rather, it simply causes Junos to ignore that interface's configuration. To completely shut off a port, you use the disable configuration command. Here, we disable interface GE0010. As you can see, the interface is now down. To reactivate it, we delete the disable configuration parameter, similar to using no shutdown to reactivate ports in iOS. Now let's take a more detailed look at the configuration of Ethernet interfaces. The EX series switches come with built-in 10-100-1000 Ethernet ports. By default, these ports try to auto-negotiate speed and duplex. You can see the details of the auto-negotiation using the command show interfaces extensive. Here's a switch port that negotiated to 100 megabits per second speed and full duplex operation. Here is a switch port that negotiated to 1 gigabit per second speed and full duplex operation. On EX series switches, many Ethernet-specific configuration parameters are contained under the Ether Options hierarchy. You can set the speed and duplex manually using the speed and link mode commands. Here, results of your configuration. You can see that the speed and link mode were set. Changing the speed or duplex settings will change only the parameters that the switch uses when attempting auto-negotiation. It will not also disable auto-negotiation. Here you see that the switch is still performing auto-negotiation with the remote side. It has auto-negotiated to 100 megabit per second full duplex operation using the parameters you configured. If you look at the remote side, you can see that it has also auto-negotiated to the same settings. If you want to also disable auto-negotiation, you must do so separately. To disable auto-negotiation, enter the command set interfaces GE004 Ether Options No Auto-Negotiation. Do that now. Junos supports the IEEE 802.3AD link aggregation protocol. Configuring links to be part of aggregated Ethernet interfaces requires 3 steps. First, you have to tell the device to create the aggregated Ethernet interfaces. Second, you must configure the device to associate certain physical links with the aggregated Ethernet interface. Third, you must configure the aggregated Ethernet interface. You tell the software to create aggregated Ethernet interfaces and allocate resources for them by setting the Ethernet device count parameter under the Edit Chassis Aggregated Devices hierarchy. In this example, we set this parameter to 1, so the device will create one aggregated Ethernet interface. Aggregated Ethernet interfaces are designated AEX, where X is a number. The switch creates the number of aggregated Ethernet devices specified, beginning with AE0 and counting upwards. In this case, because we told the switch to create only one interface, the switch will create interface AE0 only. Next, you configure the switch to associate certain physical links with the aggregated Ethernet interface. You do this by setting the 802.3AD parameter under the Ether Options sections of the physical interface. Here, we will associate GE005 and GE006 with interface AE0. Finally, you configure the AE0 interface itself. You can configure most anything under this interface that you could under the constituent interfaces. Among other things, that means you can configure 802.1q trunking. We'll set this up as a switch trunk port. Also, we'll configure the switch to run the Link Aggregation Control Protocol, or LACP, in active mode. By default, Junos does not run LACP. If you choose to run LACP, at least one side needs to be active for the link to come up. Unlike Cisco iOS, you configure these parameters only once at the aggregated interface level. So here, with just 5 commands, you've created an aggregated Ethernet bundle with 2 constituent interfaces. Here is the comparable Cisco iOS configuration. This is the end of the section. You can review the Junos and iOS code using the tabs below. Click Next to continue. Sometimes, devices send Address Resolution Protocol, or ARP requests for addresses that are not on the switch's locally connected subnet, which usually happens because the device has a different subnet mask, so it thinks the device it is trying to reach is on the same subnet. If it receives no response to its ARP request, the device will be unable to communicate with the host it is trying to reach. To assist devices that are configured in this way, switches can respond to these ARP requests with their own MAC address when they have a route to the IP address in the ARP request. This response allows the device to communicate with other hosts. This behavior is called Proxy ARP. Unlike iOS, the Junos default behavior is to not send Proxy ARP responses. To enable unrestricted Proxy ARP in Junos, you configure the Proxy ARP statement under a logical unit of a physical interface. By default, all ports that are configured as switch ports are members of the default VLAN, which Junos automatically creates. You configure VLANs under the Edit VLANs hierarchy. All you need to do is configure the name of a VLAN, and it instantly becomes a VLAN. To add a new VLAN called example, you would simply enter the command set example. Try that now. Here we see our new VLAN and the existing VLANs we already configured. You could now assign ports to the new VLAN, and it would begin to switch traffic between them. There are also a few other options you might want to configure. If you might want to use 802.1 Q tags to transmit this VLAN on a trunk port, you should assign a VLAN ID to the VLAN. In this case, let's use VLAN ID 100. Enter the command set example VLAN ID 100. Now, enter the Run Show VLANs command again to view a list of VLANs. As you can see, the example VLAN now has a VLAN ID assigned. This is the end of the section. Click Next to continue. Let's take a look at how you assign interfaces to a VLAN. There are two ways to statically assign ports to a VLAN. Let's look at the phone's VLAN for an example. Here, you see that there are three interfaces assigned to the VLAN as tagged interfaces. If you look at the VLAN configuration, you see a single interface assigned. This method is one way interfaces can be statically assigned to a VLAN. Another way to statically assign ports to a VLAN is to configure the VLAN membership under the Edit Interfaces Interface Name Unit 0 Family Ethernet Switching hierarchy. The other two interfaces were assigned to this VLAN using this method. Let's take a look at those configurations. Here is the GE003 interface. Here is the GE004 interface. By default, when you configure Family Ethernet switching on a unit, the port becomes an access port that is part of the default VLAN. You can configure it to be a member of a different VLAN by assigning it to the VLAN under the Edit VLANs hierarchy or under the Edit Interfaces hierarchy. Let's configure three new access ports, GE007, GE008, and GE009, to be members of the example VLAN. We'll configure GE007 under the Edit VLANs hierarchy. Now let's move to the Edit Interfaces hierarchy. Here, we'll configure GE007 to be a switch port. We'll configure GE008 and GE009 to become members of the example VLAN under the Edit Interfaces hierarchy. We can either use the VLAN ID or the VLAN name. We'll configure GE008 using the VLAN ID 100. We'll configure GE009 using the VLAN name Example. Let's review the configuration for the example VLAN and the three interfaces that are part of it before committing. Here's the example VLAN. Here's the first interface. The second interface, and finally the third interface. Now we'll commit the configuration. Once the configuration is committed, you can see that all the interfaces become part of the VLAN, despite the different ways we configured them. You can use these different configuration methods to assign ports to the same VLAN or to assign a single trunk port to multiple VLANs. Junos gives you the flexibility to configure your device in the way that best suits the requirements of your network. This is the end of this section. So far, we've covered configuring access ports only, that is, ports that are members of a single VLAN and carry all their traffic without 802.1q VLAN tags. This is the default mode for a switch port. You configure a port to become a trunk port, that is, a port which carries multiple VLANs via 802.1q tags, by configuring Port Mode Trunk under the Family Ethernet switching hierarchy on the interface's logical unit. Now we'll configure three ports to be trunk ports, carrying the example, phones, and printers VLANs. To be consistent, we'll continue configuring them using the three different methods we used in the previous section. All three ports are currently configured as access ports in the example VLAN. We'll start by configuring the GE007 interface to be a member of the phone's VLAN. We'll also configure that interface to be a member of the printer's VLAN. When we perform a commit check, you can see that Junos will not let you accidentally configure an access interface to be a member of multiple VLANs. One of the benefits of editing a candidate configuration rather than an active configuration as in iOS is the ability to catch and resolve errors like this prior to any of the configuration becoming active. This process allows you to resolve configuration problems before they actually affect network users. Next, we'll configure the GE007 interface to be a trunk interface. Now that we have configured this interface as a trunk port, a commit check succeeds. Now we'll configure the remaining two interfaces. Here, we configure interface GE008 to be a trunk port. Here, we add the extra VLANs for this interface. Now we'll do the same for GE009. Before committing, let's take a quick look at each of the interfaces we have configured. Now we'll commit the configuration. After committing the configuration, you see that these interfaces are now all listed as tagged interfaces for all three VLANs, that is, trunk interfaces on which a tag is being applied for this VLAN. Now let's say that you want to configure GE009 to receive untagged frames and to process those frames as part of the default VLAN. Configuring a trunk port to process untagged frames and treat them like they are part of a configured VLAN is sometimes called configuring the native VLAN. Here's the new configuration. We'll commit this change. You see that GE009 is listed as an untagged interface for the default VLAN. Even though it is a trunk interface, the native VLAN is transmitted and received without 802.1q tags. Therefore, Junos identifies this interface as an untagged member of this VLAN. Also, you see that the other two trunk ports we configured are not members of this VLAN. In Junos, trunk ports only transmit those VLANs which they have been specifically configured to transmit. iOS defaults to trunking all VLANs on all trunk ports and having VLAN 1 as the native VLAN on all trunk ports. Junos, on the other hand, trunks only those VLANs that you configure for a particular port and uses a native VLAN on a trunk port only if you configure it to do so. This is the end of the section. Click Next to continue. You can configure routed VLAN interfaces as units under the special VLAN interface that was described earlier. You must do two things to enable this. First, you assign the VLAN a Layer 3 interface. While it is not necessary that you match the unit numbers and 802.1q tags, we recommend you do so for ease of administration. Here we assign the example VLAN the Layer 3 interface VLAN.100, which matches its VLAN ID of 100. Next, we configure the actual Layer 3 interface. To make it easier to identify, we give the unit a description. Here, we configure an IP address of 192.168.100.2/24. The VLAN.100 interface is just like any other interface on the switch. You can run routing protocols on that interface, or use it just as you would any other interfaces on the switch. For your reference, here is the Junos configuration we've developed so far this chapter. For comparison, here's an equivalent configuration from a Cisco switch running iOS. You can click the tabs to compare the Junos and iOS configurations. Note that native VLAN 1 seems to be the default in Cisco configurations. Junos allows you to explicitly configure defaults and displays those parameters when you explicitly configure the default settings. However, iOS usually does not display default parameters when you configure them. Therefore, these equivalent lines are missing from the iOS configuration. Further, Cisco seems to always require a native VLAN, which defaults to VLAN 1, while Junos does not use a native VLAN unless you specifically configure it to do so. Therefore, some of the interfaces, 07 and 08, will have a native VLAN on the Cisco switch, whereas they will not on the Juniper network switch. Finally, note that iOS displays every interface in the configuration, even if it isn't configured, while Junos only lists the interfaces you have actually configured in the configuration. This is the end of this section. Click Next to continue. Now let's look at monitoring interface state. Junos software provides several ways of displaying interface state. Two basic commands are shown on screen. These are operational mode commands, so if you want to use them in configuration mode, you must preface them with run. The examples we use in this section are in operational mode. You can use the Show Interfaces Descriptions command to get a listing of interfaces and their configured descriptions. This command is very similar to the Cisco iOS command. However, note that only interfaces that have descriptions will be displayed. Enter the command Show Interfaces Descriptions now to continue. Here is the result. As you've seen already in this course, you can use the Show Interfaces terse command to get a listing of interfaces, their status, and their addresses. In iOS, to get a listing of interface status as well as the IP address if assigned, you would type Show IP Interface Brief. In Junos, Show Interfaces terse shows all configured addresses of each address family on each interface. Enter the command Show Interfaces terse now to review the Junos output. Notice that several of the interfaces in the Junos output have multiple IP addresses configured. These addresses would not have been visible using the iOS Show IP Interface Brief command. In addition to information about IP addresses and interface status, This Junos command also lets you see the brief configuration of each interface. In this output, you can see that the GE005 and GE006 interfaces are part of the AE0 aggregated Ethernet bundle. You can also see which ports are configured as Ethernet switch ports. This is the end of this section. Click Next to continue. In the previous section, we saw two ways to view a summary of multiple interfaces. Now let's look at some ways we can learn more about a particular interface. In iOS, you get details about an interface by typing Show Interfaces interface name. In Junos, you get details about an interface by typing the same command. However, in Junos, you can also add various switches to get more information or less information. Click each command to see the output it produces. When you are ready to move on to the next section, simply click the Next button. In Cisco's iOS, you would use the command Show Interfaces Switch Port to get information about a switch port, or Show Interfaces Trunk to get information about trunks. With Junos, you use the command Show Ethernet Switching Interfaces to get similar information. Like the Cisco iOS commands, you can either specify an interface, or if you don't specify one, the software will display information on all interfaces. Here we use the command to get information on the GE003.0 interface. When we add the detail flag, we can see information about whether the VLAN is transmitted with an 802.1q tag. In Cisco's iOS, you monitor VLANs with the Show VLAN command. As we've already seen, you monitor VLANs in Junos with the Show VLANs command. The iOS command will show you a listing of all VLANs. However, the listing of ports does not include trunk ports. To see trunk ports, you need to use the Show VLAN ID command. Look how several extra ports suddenly show up in the VLAN 2 listing when we use the Show VLAN ID 2 command. These different outputs can cause confusion and cost precious minutes in troubleshooting. Junos, on the other hand, allows you to get summary information with the Show VLANs command. Here, you see several pieces of key information: a list of the VLANs, the assigned 802.1q VLAN tag for each VLAN, a listing of interfaces in the VLAN, and an indication of whether they are up or down. To get more information about a VLAN, you can use the detail and extensive switches. As you can see here, the detail switch gives you the configured VLAN description, if any, the primary IP address for the associated Layer 3 interfaces, if one is configured, the total number of ports configured to be part of the VLAN, and the total number of those ports that are active. In addition to displaying a listing of interfaces and an indication of whether they are up or down, the detail switch also lets you know whether the interfaces are tagged or untagged. The extensive switch lists the origin of the VLAN, whether it was static or created through the GARP VLAN Registration Protocol, or GVRP, the time the VLAN was created, the associated Layer 3 interface, and an indication of whether each interface is a trunk or access port. As you can see, Junos never presents a partial listing of member interfaces. In Cisco's iOS, you view the MAC address table with the Show MAC Address Table command. In Junos, you view the MAC address table with the Show Ethernet Switching Table command. Of course, you can also use the detail and extensive arguments to get more information. Junos also has a feature to allow you to see a log of recent MAC address table changes. This feature allows you to quickly track down some types of Layer 2 problems. Next, let's take a look at security. In Cisco's iOS, you configure access control lists with either numbers or names. Numbered access control lists have numbers that indicate the type of access control list, standard or extended, and address family. Named access control lists also contain these indications. The Junos equivalent to iOS's access list is a firewall filter. As in iOS, you configure